Hi guys, we are jumping right in to trigonometry now. You had a review of angles last time with 1-1 and 1-2. You did a good job on the Schoology. And now we're going to get into, I'm going to start with trigonometry that you probably had in geometry. And those of you that had pre-calc had it a little bit there. And then show you how it's different from what you learned in geometry to what we're going to be doing in trig, okay? So let's look at this line that goes through the point 2 squared to 3, 2. Okay, the x coordinate is 2 squared to 3, that's about 3.5-ish. Okay, and 2. All right, so what we can do, and this is some angle theta. All right, I don't know what it is. It looks like it's maybe 30-ish degrees, right? I don't know if I'd guess. But we're just going to call it theta. What we did in geometry is we looked at these ratio of sides, which you learned are sine, cosine, and tangent. Okay, so I'm going to make this a triangle, just so it looks like what you're familiar with from geometry. This is a right triangle. Okay, sine of theta is the ratio of which two sides? Remember? Sine of theta is opposite over hypotenuse. Okay, so I just need to know the opposite side length and the hypotenuse. Okay, I made a little right triangle coming from the point 2 squared to 3, 2. Guys, if I know that point, then I know that this side length is 2 squared to 3. If you do 2 times square root of 3 on your calculator, you get like 3.46 something. It's irrational, obviously. And then I go up to 2, so this side length is 2. So I do know the opposite side, and I know the adjacent side. I don't know the hypotenuse. So think also back to geometry. If you know two sides of a right triangle, you can find the hypotenuse, right? We use the good old Pythagorean theorem. Okay, so to find my hypotenuse, I'll just put h here for now. H squared has to equal 2 squared plus 2 squared, so 3 squared. H squared equals 4 plus, I do notice that sometimes my trig students are a little rusty with their how to manipulate radicals. So this 2 squared to 3 squared. Think about it, you're taking 2 squared and you're also taking the square root of 3 squared. So this is going to be 4 times 3, right? I'm going to square the 2. I'm also going to square the square root of 3. So 4 times 3 is 12. Oh, this is nice. H squared is 16. We're just going to use the positive square root of this since this is a distance. Okay, I'm not going to say plus or minus 4. I'm doing a specific problem. Yes, the square root of 16. If I would do the square root in college algebra, we always made sure we had plus or minus 4, but this is a specific distance. It's not negative. Okay, so my hypotenuse is 4, right? So once I know an ordered pair, I know the opposite side, I know the hypotenuse side, I know that the sine of theta, the ratio of sides of the opposite side and hypotenuse is 2 over 4, which is a half. The cosine of theta, do you remember what that was? In geometry, it was the adjacent side over the hypotenuse. So I look and see, compared to theta, the adjacent side, the side that helps make up the angle with the hypotenuse is 2 squared of 3. So I have 2 squared of 3 over 4. Okay, I'm going to reduce this 2/4 to 1/2. So this is really square root of 3 over 2. Tangent of theta, remember what that was? We don't use the hypotenuse for that. I could have told you that right away before I even found the hypotenuse, huh? Tangent of theta is opposite over adjacent. Let's see, 2 over 2 square roots of 3. Okay, 2 over 2 is just 1. So I'm going to have 1 over the square root of 3. I am going to allow you in trig class to keep it in, you don't have to rationalize the denominator. okay? Because later when you get to calculus, they kind of stop with that anyway, if any of you are going on to calculus in college or anything. However, sometimes it is written, the problem with that is when it's a multiple choice answer, if you get 1 over the square root of 3 and the answer is, they write it in with the radical, out of the denominator, then I don't want you to forget that. So I'm going to, anybody that rationalizes the denominator, I'm going to give a little extra credit. So you won't lose points for leaving it as 1 over the square root of 3. However, if you would go further and write that, multiply by square root of 3 over square root of 3, and write it as square root of 3 over, what would that be, square root of 9, right, which is 3. It's the whole purpose of multiplying by the square root of 3. If you do that, I'll give you like half a point every time you do it. It adds up. Okay? But you don't have to. I don't want to. That's just a way I've found of encouraging kids to do it, but yet not penalizing you for not doing it, All right, so what I want you to notice is this. I wouldn't have had to draw. We're not going to draw the triangle anymore, okay? In trig, we use the ordered pair. We're always drawing our angles on the coordinate system. We're using the coordinate system, that algebra part, and the geometry part with the triangles, but we don't draw the triangle. The x coordinate, okay, whatever that x coordinate was, but notice that's the adjacent side. The y coordinate was this opposite side, okay? So what we do is we redefine what sine, cosine, and tangent are based on x, y, okay, your xy coordinate, and a new letter r. We use r for the hypotenuse. The reason is, guys, r is like the radius of a circle. That's a horrible circle, but the circle that has the origin at the center and goes through this point. Okay, so just go with it. Okay, instead of hypotenuse, we call it r, and r squared equals x squared plus y squared. Right? We did that. That was the Pythagorean theorem. Okay, so we are redefining this. The sine of theta is now not going to be opposite over hypotenuse. The sine of theta is going to be y over r. Okay, let's go back. Right? What did we get? We got 2 over 4. That ended up being our y coordinate over what we got for our hypotenuse. It's y over r. The cosine of theta ended up being the x coordinate over r. Okay, and so that's what we call cosine. Some of you that had pre-calc will probably recall this. The tangent of theta, remember we didn't even use the hypotenuse. The tangent of theta was just the y coordinate over the x coordinate. Tangent of theta is y over x. Now, I believe you learned the reciprocal trig functions. Cosecant is the reciprocal of sine. So cosecant will obviously be r over y. Tell you the truth, I don't really memorize these. I just know to flip sine if I need cosecant. But there's lots of different ways to do it. You can, just for completeness, I'm going to write these. Okay, cosecant is r over y. Secant is the reciprocal of cosine. So secant is r over x. And cotangent is the reciprocal of tangent. So cotangent is x over y. Okay, so you can fill those in your notes. Notice where theta is. Theta is the angle that's, look, I'm still starting on the positive x-axis and rotating until I go through this xy point. Okay? This is some xy point that my line is going through. I don't really have to draw it that often. If I have these, after a while, believe me, you'll have these memorized. That sine is y over r, cosine's x over r, tangent's y over x, and the reciprocals. Okay? Hopefully you have those in your notes. These are the formal, this is right out of your book. Now that you guys are going to be in class, you'll be getting your book. You can see these right in your book. This is the mathy way, okay? We just kind of proved it together, so it made sense. Let xy be a point other than the origin on the terminal side of an angle theta. in standard position. Okay, so all that sentence is what we did in 1.1 and 1.2, just making sure you understand what terminal side means, standard position, what that means. That means the initial side is on the positive x-axis, and we're opening. Okay, we're opening and going to the terminal side. The distance from the point to the origin is, of course, this. We showed why. That's just Pythagorean theorem. That's r squared equals x squared plus y squared, but they went ahead and did the square root. Okay. The 6 trig functions of theta are defined as follows. You just wrote that down. So you already have these notes, but I have it in your notes twice. I'm sorry. I really want to make sure you get this. I just noticed that. Sine of theta is y over r. Cosine theta is x over r. This is just for completeness. They wrote, hey, by the way, when it's y over x, x can't be 0. Notice they didn't have to write that when r was on the bottom because we've already defined that r is the positive square root of x squared plus y squared, and we're not on the origin. So we have some distance, okay? Anyway, notice you just have to realize the denominator can't be 0. Of course, we're undefined. Okay, so that's that. Now let's practice. Let's sketch an angle theta in standard position such that theta has the least possible positive measure and the point -3, -4 is on the terminal side of theta. Then find the exact values of the 6 trig functions of theta. Okay? So, I think I have, if you printed your notes out, you have some graph paper here. I'm going to graph the point -3, -4. I'm going to have to scroll down to do that, huh? 1, 2, 3, 1, 2, 3, 4. Do that first. Okay. This is just sketching the angle. My terminal side goes through there. My initial side, of course, is always right here. You don't have to draw that part if you don't want, but I usually do. This is the theta we're talking about. We're not talking about, the reason they said small as possible is we realized I could go around an infinite number of times and it would still be this terminal side. I could go in the negative direction and that could be the terminal side, okay? We want standard position such that theta has the least possible positive measure. You have to read all that. That was why last chapter was so important. Okay, what was the point again? -3, -4. Okay, sometimes I write off to the side, x is -3, y is -4. Now we need to find r, don't we? So we're going to have to take -3 squared plus -4 squared. This is my favorite triangle. So we get 9 plus 16, square root of 25. Wonderful. R is 5. Okay? Got it? After that, it's just, as long as you understand the ratios or memorize them, the sine of theta is y over r. The cosine of theta is x over r. The tangent of theta is y over x. Oh, that's actually, don't write it like that. Write it as positive 4/3. Okay, a negative over a negative is positive. The cosecant of theta, I'm just going to flip this, okay? It's -5/4. It doesn't matter where the negative is. A lot of times we just put the negative out in front, actually, okay? The secant of theta is -5/3. The cotangent of theta is 3/4. Okay? What do you think? Not too bad? Good. I'm assuming you said not too bad. All right, let's try this one. Okay, you can pause it here. Obviously, it's I'm going to do this one on the next video because time's running out. But if you want to, while you're getting the next video ready, you can try this on your notes. That would be an awesome idea so that you can see if you got it on your own or not. All right? Well, the x-axis is right in the middle of my face. That was nice. Okay. See you guys. Bye.